Hello everyone and a very good day to Dr. Tan. My name is Perywiswaran A. Pandeun. My matrix number is 231110991 and I'm from group 56. Today about laboratory 2 we'll be focusing on the title of effect of obstacle material on recorded sound amplitude using smartphone recording. So, the research question that has been obtained during this experiment is how does obstacle material affect the recorded sound amplitude of the audio signal? The objectives are to investigate the effect of obstacle materials on sound reduction to analyze sound signals in time and frequency domains using CLAB. So, the independent variable is the obstacle material that is being used in this experiment, which is A4 paper, cardboard, and folded towel. The dependent variable is to calculate the maximum amplitude for each obstacle material in this experiment. So the hypothesis that is being obtained with the aid of Richard's question is if the sound wave passes through denser obstacle materials, then the recorded sound amplitude will decrease because more sound energy is absorbed and blocked by the material. So as per you see, the figure 1 shows the experimental setup using the cloth as material. So the tablet was used to play the given assigned audio signal, while the smartphone is used as the recording device. The obstacle material, which is the cloth, was placed between the tablet and the smartphone. And then the materials, the one tested after the cloth was A4 paper, cardboard, and folded towel. The ruler was used to maintain a fixed distance of 35 centimeters between the smartphone and tablet. Several conditions were focused, which is same wave file, same volume 100%, same distance 35 centimeter, and same recording duration 10 seconds. The safety precautions are conduct experiment in a quiet environment, keep devices stable during recording, and use safe sound volume. So everyone might be wonder when the safety precautions is using safe sound volume, why you using same volume, which is 100%. So since the environment was very quiet, so I allow myself to make the volume to 100% so that I can get a clear recording to make sure the CLAB will analysis it my graph more better. So as you can see, table 1 shows the raw data obtained from the CLAB analysis. So these are the values of maximum amplitude and also the peak frequency that have been obtained from the CLAB analysis itself. So the below shows the coding of each for how I collected the data from the CLAB using the recorded audio signals. So for peak frequency, the FFT spectrum was used first, then max was used to locate the highest peak in the spectrum, and the related frequency value was taken from the frequency axis. The maximum amplitude values were extracted using the command max apps. The apps function was used because the audio signal has positive and negative values, while max was used to find the highest amplitude value. So to make sure the comparison looks more easier and effective, I added the percentage reduction to for all the materials that we used during the experiment. So cardboard produced the highest reduction, which is around 95%, and A4 paper produced a reduction of 10.1%. For folded towel, a negative reduction value was recorded because the recorded amplitude was slightly higher than the no barrier. All materials recorded almost with the same peak frequency, which is 1496.1 Hz. There, this shows the obstacle materials affected the amplitude more than the frequency. So as you can see, for the CLAB analysis, the figure 2 shows the time domain signal and frequency spectrum obtained using CLAB. In the upper graph, which is represent the time domain signal, and the lower graph, which is the fast Fourier transform frequency spectrum. So as you can see, the cardboard waveform shows the smallest amplitude among the all tested materials. This agrees with the raw data where cardboard recorded the lowest amplitude value. So as you can see, this is uh, this is expected because the original sound source remains the same throughout the whole experiment. The obstacle material is the one changed the signal strength reaching the microphone, but the frequency of the source remains almost unchanged. So At the side, there is a brief CLAP coding that have been shown, which is only focusing on the no barrier recording file. So the more explanation about that CLAP coding, the FFT function was used to convert the signal from time domain to frequency domain. The wave read was used to import the no barrier audio file into CLAP. The max and abs function was used to obtain the maximum amplitude. Finally, plot was used to generate the frequency of graph. The same analysis procedure was repeated for A4 paper, cardboard, and folded tower recordings. So, on to the next slide. The discussion. The results that is been obtained to support the hypothesis has been accepted. The cardboard recorded the lowest amplitude value of 0.0351 and the highest reduction percentage. This suggests that cardboard was the most effective material among those tested in reducing the recorded sound signal. A4 paper also reduces the amplitude, but the reduction was smaller, possibly because the material might be thinner. An interesting result was obtained for the folded towel. Instead of reducing the amplitude, the recorded value was higher than the no barrier. Possible factors that can be obtained to this result, which can be included, the environment was not completely silent, and the limitations of the smartphone microphone, and also the sound reflections from the nearby surface that has been used during conducting the experiment. So, since a smartphone was used as the recording device, the measurement accuracy might not be as so precise as a normal sound measurement equipment. But despite the unexpected result, the overall trend still shows that cardboard produces the greatest reduction in recorded amplitude. So, for the conclusion, the effect of obstacle materials on recorded sound amplitude was successfully investigated. Among the material tested, cardboard produced the greatest reduction in amplitude and recorded the lowest maximum amplitude value. Based on the result obtained, the overall was consistent with the prediction made before the experiment, where denser materials were expected to produce greater sound reduction. Therefore, obstacle materials were found to have a greater effect on sound amplitude than on sound frequency. That's all from me. Thank you so much.